All right, so today we're going to talk about descriptive statistics. And the first thing we're going to talk about is your measures of spread. So your measures of spread contain your range, which you guys know your range. You should know your range. It's where you take your highest number and subtract your lowest number. Now, your interquartile range is basically the same thing, except, now remember when we were making our box plots, we had the Q3 and the Q1. So interquartile range is where you say Q3 minus Q1. And then standard deviation, we're not going to do the formula. Desmos does it for us, and I'm going to show you how to do that in just a minute. But it's how close the entire set of data is to your average value. Now, what you need to remember is that your average value is your mean. Okay, so if I was to replace that with mean, so your standard deviation is how close an entire set of data is to the mean. All right. Now you need to remember that for when we for tomorrow's lesson. Okay. All right. Now, these are all what they look like, especially if you were doing it in a calculator. Okay. But we're not. But I just want to still show it to you. So X with a line over it means the mean. This big E means sum, and it's saying the sum of my data. So it's saying the sum of your data. S of X is sample standard deviation. Remember, sample is not the whole thing, and population is the whole thing. And that is population standard deviation. N is how many terms you've had, and we've gone over these already. So the first thing we're going to do is we're going to go through again of how Desmos can do all of this for us, okay? So I want to find the mean, median, mode, and range. Now, it cannot find mode because mode is just which number occurs the most. So looking at this data, the number that occurs the most is going to be 28. So I'm going to put 28 here, okay? Now, it does the rest for you. So let's go up there and let's find all this stuff, okay? So let's pull this up, and we're going to go to Desmos. So the first thing you have to do is just like we did, is you have to type your list in. Okay, so we're going to type in our list, and how we did it, remember we said L for list, and then we said equals, parentheses, and you're going to type your numbers in, 40, comma, 28, comma, 28, comma 34, comma 24, comma 32, comma 45, comma 28, and comma 39. So there's my list. Did I do something wrong? Oh, it's supposed to be brackets, not parentheses. JK, guys. Brackets. There we go. All right. So now I want to find my mean, median, mode. Remember, that is your 5-number summary. Okay? So we pull up our keyboard, we do functions, we go to statistics, and I want my 5-number summary. Now remember, to find all that information that we wanted, we learned this when we were doing box and whisker plots. To find what we need, we just type stats, parentheses, L, and that gives us our 5-number summary, okay, which is some of the stuff we needed. Okay, so our min is 24, our max is 45. So one of the questions was, what is the range? So to find the range, you have to take high number minus low number. So to find the range, we got to say min minus max. So that needs to be max minus min. So range is max minus min, okay? So my max is 45, my min is 24. So 45 minus 24, if you forget, oh, it went away. So I'm going to say to find my range, I need to say 45 minus 24. So my range is 21. Wrong one. 21. Okay. My mean and median. Remember, your median is your Q2. So Q2 is, oh, it says median is 32. So this is 32. Your mean is your average. Now this does not give you your mean, but if you go to functions and statistics, you see how it says mean right here? Say mean of L. So my mean is 33.1. So we're going to say 33.1. Now, interquartile range, that is your Q3 minus your Q1. My Q3 was 39.5 and my Q1 was 28. So let's do it in decimals. So I'm going to say 39.5 minus 28. And I get 11.5. So that's my interquartile. Now to find your standard deviation, that is also under statistics. See how it says standard deviation right here, abbreviated? I want the standard deviation of L. Done. 6.56. And that's all you have to do for those. Okay? All right, so let's do number 2. I'm going to type it in. All right, so what I would do, since I have everything I want up here that I know I'm going to have to do, well, minus that, I'm just going to change my list. So I'm going to come up here and I'm just going to backspace all this. And I'm going to type my new list in. And I've already got the information up here, so it's just going to calculate it for me. Okay? So I'm just going to type my list in. 8.4, comma, 7.7, 8.6, 7.5, 8.9, 7.8. Oh, didn't do it. 7.8, then 8.6, 9.1, and 8.0. Okay? So then it just finds it all for me. Okay? So I really don't have to change. I mean, I already have it typed in, so why not just change your list? Because that's the only thing that's changing. So I need my range. My range is going to be your max minus your min. So I'm going to say 9.1 minus 7.5. So my range is 1.6. Okay. Mode, which number occurs the most? Well, looks like I got two 8.6s. There's only one 9.1. There's only one of those. 7.8, only one of those. So 8.6 is my mode. Remember, mode is what occurs the most. The median, I get that from that stats list, and the median was 8.4. Okay. Your mean, I already have it up here. Here's my mean right here. It is 8.29. 8.29. Interquartile range is your Q3 minus your Q1. So I come back up here and I'm going to say Q3, which is 8.75, minus my Q1, which is 7.75. So that's going to be 1. Standard deviation is just going to be this other right here. Standard deviation is right here. And it's going to be 0.53. And that's all you have to do, guys. Okay? All right, so the next we're going to talk about a few things. All right? Oh, there we go. All right, so we're going to talk about symmetry versus skewness. A distribution is skewed if it is not symmetric and it extends to more than one side than the other. So you can have two types of skewedness, okay? You can have a skewed right. So we're going to do the bell curve, which is, you're going to learn more about the bell curve tomorrow. But a skewed right would mean that its right side is going to have a tail on it. We call this the tail, okay? Wherever your tail is where you're skewed. So see how my tail's on the right here? So this means I'm skewed right. If your tail was on the left, it means you're skewed left. Okay, so this means I'm skewed left. Okay? Now, a distribution is symmetric is that the left half and roughly mirrors the image of the right half. So a symmetric one is going to look like it says, symmetric, okay? Now, you know, I can't draw symmetric, but symmetric is where you can't tell where the tail is. It looks like it's on both, so this would be symmetric. Now, in a perfectly symmetric distribution, the mean, median, and mode is right down the middle. Like this right here would be my mean, my median, and my mode. Okay, if you come across a set of data where your mean equals your median and it equals your mode, that is a symmetric set of numbers or a graph. Okay. All right, the mode is always a value at the hump in the distribution, and the skewedness has a greater effect on the mean than the median. Okay, so if something's skewed, it's going to pull that median. All right, that's what that means. Now, when the data are skewed to the right, the tail of the distribution extends to the far right, and we say that's distributed positive. So you can say positively skewed, or you can say right skewed. Okay? It means the same thing. But what it means is that it means that when you look at the graph, you've got a tail on the right. Okay? Now, negatively skewed means that it's skewed on the left. And again, that means your tail is going to be on the left. Okay? The mean is affected by the skewness the most. Okay? So if something's skewed, it's going to affect the mean more than it's going to affect anything else because the mean's the average. So if you have an outlier over here at -1, but most of your data is over here, that -1's going to skew it. It's going to pull it. Okay? So it depends on how big of an outlier it is of how much it'll skew you. Okay? So that brings us into outliers. An outlier is either way bigger than your data set or way smaller than your data set. So like if you had a data set of 2, 3, 4, 5, 30, 9, and 10, 30 is an outlier, okay? And it's going to skew your data to the right. Okay, it's going to pull it closer to that 30. An outlier will affect your average greatly, which is your mean. So for each of these graphs, I want you to state whether the graph is skewed left, right, or symmetric. So what I do is I kind of do a curve. So see how the tail's over here? This is skewed right or positive, okay? And that's an outlier right there, okay? This guy, when you trace it, that looks pretty symmetric, doesn't it? So this is symmetric. This guy, when I draw the stuff, where's my tail at? It's over here, which is on the left. So that's skewed left. It didn't have any outlier, but it was still skewed left. Okay? All right. So that's it. You're going to have another video on how to describe graphs, and that'll be it for today.